Hello, Year 10s. This is a video on, we're looking at 4C, which is really just applications of what we're looking at before, 4A and B, looking at trig ratios, looking at inverse trig ratios. And the first thing we're going to start with is there's two words, which if you don't understand what they are, you're going to have a rough time of it. And that is angle of elevation and the angle of depression. And if you're in my class right now, you should be probably getting your highlighter out and highlighting those. Now, angle, elevation and depression, they are always, if you want, trying to remember which one it is, it's always the angle to what we call the horizontal. So the horizontal being, for example, if I had a ladder here, the horizontal angle is always the angle to the ground. And this over here is what we call the angle of elevation. So this angle here, I might call this theta. That's my angle of elevation. A lot of the time, students, you might be given some angle here. I might call this angle phi, another letter in the Greek alphabet. But of course, that angle there isn't the angle of elevation, is it? We'll need to subtract that angle from 90 degrees to find my angle of elevation. So be very careful. If you're given this angle here, let's say you're given that angle is 30 degrees, then the angle of elevation is always going to be, in this case, it'd be 60 degrees because it's always from the horizontal. Okay. Now these, just building on what we've done before, just remember we're looking at, you've got to make sure that you can visualize and draw right angled triangles in a given situation. Use your trig ratios just like we did in the previous section in 4A and B. And finally, of course, answer it in words. Nothing new as far as content, but reading and interpreting the question is really important. What we're going to be looking at is applying trig with worded problems, using angle of elevation and depression, and also solving other worded problems. Okay, so that's what we're going to be doing. Not going to take us too long. Let's go through and do this one together. Then I'm going to get you to have a go in a second. It says a helicopter is hovering at an altitude of 250 meters. It's quite nice because we've been drawn a picture. We're not always going to get a picture, are we? So 250 meters is here. And it says that the angle of elevation from the helipad to the helicopter, angle of elevation, it's from the horizontal. Okay, so that is 35 degrees. Find the horizontal distance. The horizontal distance being this one here, question mark. Let's call that an X if you like. And let's go ahead and do this. Now, first of all, before we do this, I'm going to ask this class, I'm going to pause right now. We just had a brief discussion. Step one for any trig problem is you need to label the triangle. If you can't do that, good luck doing SOHCAHTOA. You're never going to be able to do it. We need to label the triangle with OA and H, which we've just done. Step two is we need to find out what trig ratio we're using. So what trig ratio are we using? Well, if you have a look here, if you know SOHCAHTOA, we're looking at an opposite and we're looking at an adjacent. We don't really care or give two hoots right now what the hypotenuse is. Yes, we could find it later if we wanted to, but for the time being, we are looking at the opposite and the adjacent, which means we're using what? You can shout it out. If we're using opposite adjacent, which trig ratio are we using? We're using tan. We're using tan because we have the opposite. Well, we have the opposite and we're trying to find the adjacent. We know what the angle is, so let's write out. Step three is write it out and then solve it. So we've got tan of 35 degrees is equal to my opposite, which is 200. Now, you know what? If you were to write this, you're probably entitled to about half a mark out of 2. So if you did that and you then made a mistake, I'd at least give you marks for doing that because you've recognised the right trig ratio. Of course, if you went straight to here, that's also okay. We know that O isn't just O, it's 250. And A is an A, it's actually X in this case. Okay, so there we go, tan of 35. Now, step three is we need to solve the equation for our unknown. Now over here, we just had algebraic fractions last time. I said that it's probably a nice thing. If I turn that into a fraction, put that over 1, where can the x go?
Where the 10.
Yeah, where the 10 is, that can go and swapsy over there. Do a little swapsy. Notice there. If you do that, you are sweet to go. Now, by the way, if you really are struggling with that algebraic concept, it'll take you a little bit longer, and I'll show you right now how to do it in a CAS calculator without even knowing how to do the algebra. Mind you, I still want you to be able to do the algebra, all right, and do it by hand. But this is how you would do it with a CAS. See here, I've got tan of 35 is equal to 250 over x. If you wanted to, the power of these calculators, especially if you were going into general maths, there's a lot of stuff that you don't have to do by hand anymore if you indeed go on to further maths and general maths, because your calculator is in every single class, assessment, test, everything. The whole year you can use it in general and further maths. You cannot use it for everything in methods and or specialist. Okay, so it's obviously going to be one of the disadvantages if you are in methods or specialists. You can't just rely on your calculator. So what we're going to do is I'm going to solve. I'm going to go menu 3-1 solve, and we're going to solve. We're going to write exactly this. We're going to write tan of 35, and I'm just going to write exactly like that. Hopefully your calculator is in degree mode, which is up there. It should say DEG. And let's go solve trig tan of 35 degrees is equal to, let's do this. And we are looking for 250 over x. If I press enter, the calculator is going to not be so happy. What do we have to do? Comma x. Thank you. Now, you're going to get this. That's not going to be very helpful for us. That's just an exact value. So we have to hit control and enter. There you go. 357.03. So there you go. There's our answer. An easier way to do it, though, is if I simply just had x, and x goes where tan 35 is, x is equal to 250 over tan 35. If you can just rearrange like that, it's going to be a little bit faster. Yes, you have to do the rearranging, but notice if I just did this, what's faster, what we did there, or if I simply just had 250 divided by tan of 35. What's faster? This one. This one's way faster, isn't it? But this one, if you're a student that struggled with the algebra, you could do it that way. It would take you longer, but depends. Hopefully you understand why it's this. Okay, and if you do, then you're going to get it faster. You're going to get it right more often. 357 says to the nearest centimetre. So, well, okay, we're looking at metres, by the way. So that's 357. What about how many centimetres in a metre? Sorry? 100. So would you agree that I'd have to move 2 decimal places over? So it's 35703. 35703. Let's round up to the nearest centimetre, though. So it's 35704 centimetres.
Right.
It's asking for the nearest centimetre. We're being given in metres. So we had 35703.7, okay, centimetres. We needed to round off. So that rounds off to that. Be very careful. Now, you as students, I'd like you to try this one now. I'm going to pause this video. If you're watching this, I want you to try and pause this now, and I'm going to reveal my answer in about 3 seconds. If everyone in this class, please try it now. Okay, if you're watching this at home, we have gone through this in class, and if you indeed got 7,002 centimetres, we have 70.02 metres, so we needed to move 2 decimal places. For starters, we had the opposite and the adjacent, the opposite being 100, x, and of course we can rearrange that, we can cross multiply, and x is equal to 100 over tan of 55 degrees. Ella, I just went through that. Multiply it by 100 because we've been asked for centimetres, okay, not metres. Right, let's quickly go through this one. But before we do, this time we don't have a diagram. So let's draw this out. We've got two buildings which are 57 metres apart. One's 237 metres high, so we'll draw that. And that's 237 metres. And this one here is 158. Now it says that they are 57 metres apart. And we've been asked to find the angle of elevation from the top of the shorter building to the bottom. So we're trying to find this angle in here, theta. Now, if I do that, let's get this triangle, which by the way is a right angle, and let's draw it over here. We don't need to draw windows in the buildings or draw little birds flying. We just need that triangle, don't we? So if we do that, there's our triangle. Now we don't want 237. We want 237 subtract 158, which is 79 metres. We've got 57 metres over here. And because we've got some unknown angle, we might as well use theta. You don't have to use theta, that's fine. You can use alpha, beta, gamma, delta, all letters of the Greek alphabet. Omicron, pi, phi, theta, zeta, go for your life. If you want to add or do any letter of the Greek alphabet, go for it. But just use theta. All right. Now, we want to find this. So we've got, of course, we've got opposite the angle. This is the opposite. We've got the adjacent. Whenever you have the vertical height and the horizontal, often you do have tan theta as your relationship. So let's do that. We've got tan of theta is equal to opposite 79 over 57. And of course, we should hopefully know that we're using the inverse tan. Why are we doing that? Because we're doing the inverse tan of the left-hand side. This is the long way. We're doing the inverse tan of the right-hand side. Those are going to cancel out. Theta is equal to inverse tan of 79 over 57, which, Josh, what was that approximately equal to? 54.19 degrees. That's our angle of elevation correct to 2 decimal places. Okay, now look, you could by all means try this. I think that we've literally just been through one exactly like that. Feel free to try this one now, and I'm pretty confident that it's very much the same. We're going to stop there.